in Lesson 56, starting on page 399. This is finding angles of rotation. Kind of move that guy over there a little bit. All right, we want to do some reading. We're going to talk about angles of rotation, and there's about 4 things that we need to know, 4, 5, 6 definitions that we need to get in. We'll look at some trigonomic functions, but some of that stuff's already kind of been done for us up to this point. But our terminology in terms of angles of rotation is going to be really important for us to get. All right, so we want to look at some of the things that are stated in that box on page 399 in your textbook, where it talks about angles of rotation. Okay, the first thing it's going to mention is standard position. Okay, let's see. Diana, are you on this page? If I have you read something, are you ready to go? Okay, can you tell me what standard position is?
An angle is said to be in standard position when its vertex is at the origin and one ray is one positive x-axis. Okay,
so let me kind of state that again, just because you probably can't hear her on the recording. But it's when an angle has its, because I kind of have to rephrase it, has its vertex at the origin and one ray is on the positive x-axis. Okay, standard position. All right, so let's kind of look at standard position. Now, all this is going to be based upon a coordinate grid, but we're taking the coordinate grid and we're not looking at specific coordinates, but we're looking at angles based around, sorry, all right, around that origin. All right, angles of rotation. When an angle has its vertex at the origin and one ray is on the positive x-axis. So what that'll look like is this, all right? If I've got, okay, we've got our x and y, our axis, and let's get our angle. So standard position would be something like this. Okay, we've got, let's see, when an angle has its vertex at the origin, so we're at the origin here, and one ray is on the positive x-axis. That's this line right here, positive x-axis, not over here, okay? Standard position is where that angle is, that blue line, and I can move this secondary red line, okay? I can move that all the way around, okay? I can move that anywhere, but the standard position has to leave this right here on the x-axis. That's my standard position, okay? All right, let's move on to another piece of terminology. The terminal side. Okay, let's talk about the terminal side. Terminal side. Christian, could you read or explain that to me? Okay, so terminal side is that ray that is not on the x-axis. So going back to what we looked at earlier, okay, if I've got this, all right, this is not the terminal side. The terminal side is the ray of the angle that is not on the x-axis. So that would be this length right here. Okay, this is still my angle. Okay, but that red line right there represents my terminal side. Okay, does that make sense? Okay, we are starting from that blue line and we are ending at the red line. Okay, we're going to end at the terminal side. All right. Which brings us to the next part, the initial side. The initial side. Let's scroll down here and talk about the initial side. Okay, let's underline this. If I can. There we go. Okay, because that's what we want to look at. Oh. Okay, the initial side. Let's see, Lexi, would you tell me about the initial side?
The initial side of the angle is located directly on the x-axis.
Is located directly on the x-axis. Okay, so if the red line is the terminal side, which ray or side is the initial side? The blue line, okay? The ray of the angle that stays on the positive x-axis is my initial side. Okay? Okay. All right, now we want to talk about angle of rotation. Okay, angle of rotation, which is a whole little paragraph down below that. Let's see. Sitlali, can you read that for me? Okay, an angle formed by rotating the terminal side and keeping the initial side in place is called the angle of rotation. Okay? All right, the terminal side can be rotated more than 360 degrees. The terminal side can be rotated more than 360 degrees, which means we can go around the origin multiple times. In fact, we can go around as many times as we want. All right, now, you should see in that chart below it some more information, and we're going to talk about that information here. Okay, we're going to talk about angles of rotation. Now, I'm going to try to keep this consistent so we're seeing our initial side stays here. Okay, but some other things that you want to know. Okay, let's talk about positive. Okay, a positive angle and a negative angle. Positive and negative angles of rotation. Okay? In a positive rotation, we go counterclockwise. Okay? So if you think about how the hands of a clock go, we would be going in the opposite direction that the hands of a clock go. Negative rotation goes clockwise. Okay? In a positive rotation, this is at 0 degrees. Then it goes up to 90, which is right here. Then 180. Then 270. Okay? In negative rotation, this is negative 90, negative 180. Okay? Negative 270. Okay, and this is still 0. Okay, so this is going to go from here, this direction. This is going to go from here, this direction. Okay, we'd follow our terminal side on around those ways. Okay, any questions about that so far? All right, we do have one more bit of information before we get started here, and that is coterminal angles. Coterminal angles. Okay, coterminal angles, actually, and then we'll have reference angles also. So, coterminal angles, I'll go ahead and read this for us. These are angles that share the terminal side. Okay? Coterminal angles are angles that share the terminal side. They go on, they say, for example, the angles 90 and 450 degrees come to the exact same location. Okay? 90, if we go back a slide, 90 is right here. Okay? But if I continue to go around This would be 360, and then I would go another 90. That I would be back at that same position whenever I got to 450 degrees. Does that make sense? Okay? So 0 and 360 are coterminal. You follow me? Okay? And I could do the same thing with the negative, right? Negative 180 and positive 180 are coterminal. They end at the same position. You follow me? Okay, great. Okay, now let's talk about reference angles. Okay? Okay, reference angles. Now, you should see this at the top of page 401. An angle with measurement theta in standard position forms an angle with the x-axis. The acute angle formed by the terminal side of the angle of rotation in the x-axis is called the reference angle. Okay, so I'm going to write that the acute angle formed by the terminal, and it will help if we type and we can spell, formed by the terminal side of the angle of rotation and the x-axis. Okay? So to give you something of an example here, if I have this, okay, this is my initial side. Let's say my terminal side came out to here, okay, and I knew that this was, let's say, 150 degrees, okay. My reference angle, right here from here to there, okay, because it will always be the angle between the terminal side and the x-axis, okay. If that's 150 degrees, then my reference angle is 30 degrees because this is at 180 degrees, okay. So we can draw, in the reference angle, what they say in there, if you follow that last part, is that a reference angle is always going to be less than 90 degrees. Okay? Okay, that's what it says. Reference angles always measure less than 90 degrees. Okay? And I can do this from anywhere. Okay? So I can draw it here, in which case my reference angle is going to be there. Okay? Here, my reference angle would be between here and here. There, my reference angle is going to be between here and here. Okay, and they're not always going to be the same measure. It's however, whatever the distance is in degrees from my terminal side back to the closest x-axis. Okay? All right, let's see if we can answer some questions with the time that we've got. Okay, lesson 56. What is the measure of the reference angle for 125 degrees? All right, so keeping in mind, this is my initial side. 125 degrees is going to take me into the second quadrant. So my reference angle is going to be the distance from here to here. So if I know that this is 125 degrees, what math do I have to do to find my reference angle? Subtraction. What am I subtracting, Emily? 180 minus 125 is going to tell me the remaining degrees that exist, which is 55 degrees. And our reference angle will always be positive. Okay? I get 55 degrees. How many of us, we don't understand that? Anybody here not understand how we get our reference angle? Okay, everybody feels pretty comfortable there. Okay? Let's look at our next question, number 2. We want to draw 728 degrees in standard position. All right, is 728 degrees, is that positive or negative? Positive. So which direction am I going to go? Clockwise or counterclockwise? Counterclockwise. So I'm going to start from the initial side, and I'm going to go around, all right, counterclockwise. Okay, so we could probably look at some of these and see where they start from and why they don't work. Okay, do we notice on A, does it start from the positive x-axis? No, it doesn't. So we can get rid of A. All right, does B start from the positive x-axis? No, where does it start from? Starts from the positive y-axis. Okay, so we have to start from our initial side. Okay? Does C start from the positive x-axis? Yes, it does. Does D start from the positive x-axis? No, starts right there. Starts at the negative y-axis, right? Where it starts from is going to be that most inner part, okay? All right, so this, we know that C is our answer, but let's consider this. Okay, from here to there is how many degrees? 360, okay? And if I go around again, I've added another 360 degrees to it, right? What's 360 plus 360? 720, and I want how many degrees? 728. So that's where I go up just 8 more degrees. And that's where I'm getting that line right there in standard position. Okay? So 8 degrees and 728 degrees are coterminal. Does that make sense? Yes, maybe, hopefully. All right, so we should understand not only why C is correct but why the others are wrong. All right? Find the measure of the reference angle for theta if it's a negative 147 degrees. Okay? So, am I going clockwise or counterclockwise? Clockwise. All right, so I'm going this way. That's how many degrees? Negative 90, right? How many degrees is this line right here? Negative 180. So I am between negative 90 and negative 180 degrees, right? Okay, so I should get a line there. This is going to be negative 147 degrees. Okay, I want to know how many degrees it is from there to there. So what I can do is I can take, what, negative 180 plus 147, find out what the difference is. Negative, well, okay, so you're getting, but is my reference angle ever negative? No, I should give me a positive 33 degrees. Positive 33 degrees. Okay? Reference angle is always positive. All right, let's erase that one. Hopefully we can get through all of these. I think there's only about 5 questions. So, all right, find the measure of the reference angle for the given angle. Express your answer in degrees. Reference angle again. 225 degrees. Again, this is my initial side. Am I going clockwise or counterclockwise? Because my angle is positive. In which quadrant am I going to be in? Am I going to be in the first quadrant? No, because it only covers 90 degrees. Am I going to be in the second quadrant? No, because it only covers up to 180. Am I going to be in the third quadrant? Yes, because it covers clear up to 270. So I know I'm going to be in here somewhere, correct? So let's kind of follow what we've said before. Here to here, okay, is 225 degrees. Okay, but I want back to there. That's my reference angle. So what do I need to do? 180 minus 225? 225 minus 180. Okay? Okay, what's 225 minus 180? 45 degrees. Okay? That angle, the reference angle, is always the angle between my terminal side and the x-axis that it's closest to. Does that make sense? Okay, so even if we've gone past the x-axis, we might have to subtract back to it. Okay? Number 5. Okay? Find the measure of one positive and one negative coterminal angle with 46 degrees. Okay? So if I've got my initial side, which quadrant is 46 degrees going to be in? The first quadrant. Okay? So we're saying that from here to here is 46 degrees. Okay, let's find a positive degree that's going to get to the same position. The only way to do that is to go all the way around. Okay, so what math do I need in order to find a coterminal angle there? first coterminal angle positive that we can do? I'm going all the way around plus 46 degrees. So Corey, what is my math? 360 plus 46. Okay, well, what is that? 406 degrees. 406 degrees is coterminal with 46 degrees. Now, I want to go this direction back to that same position. Okay? So this is going to be negative. It should ultimately be a negative degree, okay, because I'm going clockwise, correct? So here I've got negative 90 degrees, I'm at negative 180 degrees, I'm at negative 270 degrees, okay? How do I find out from there to there? Every quadrant has how many degrees? Has 90 degrees, okay? But I want to stop 46 degrees short of it. You could do 360 minus 46, sure, okay? 360 minus 46 is what? It's 314? Is it 314? Okay, now there's only one thing, okay? Is this positive or negative? It's negative because I am going clockwise. So negative 314 degrees. So I should get 406 degrees positive, negative 314 degrees negative, okay? Those are, now, I could get any number of these, because I could get an infinite number of coterminal angles because I could continue going around and around and around as many times as I want, so long as I stop at that same terminal side. Okay? How many of us are kind of thumbs up, sideways, thumbs down? Anybody thumbs down, don't get it at all? Okay. Everybody looks like they've got a pretty good understanding of it. I'll get this video posted as soon as I can. And you guys can start on your homework right